Welcome to the Explainer. So we've all seen the hype. AI can write code. But the real question is, what happens when things get tricky? Can it handle the really specialized stuff? Today, we're diving into two super interesting papers that show how you can take a generalist AI coder and turn it into a specialist, a real expert. That's right. We're going to look at EfficientUICoder from Jingyu Xiao and their team, which is all about making UI generation more efficient. And then we'll get into From Evaluation to Enhancement by Zhentong Xu's team, which tackles the mind-bending world of cryptographic code, where being correct isn't just a good idea, it's everything.
All right, so let's set the stage with our first section, the AI Coding Challenge. And the subtitle here really says it all: when good enough isn't good enough.
So, Theo, let's just jump right in. We know an AI can spit out a basic Python script, no problem. But where do the cracks start to show? Where does it really begin to fall apart?
Well, it really struggles when things have to be perfect. When precision and efficiency are non-negotiable. It's the huge gap between writing a simple hello world script and building a highly specialized mission-critical program.
Right, and you can see that difference really clearly here. On one side, you have what we call mainstream code, like a basic login function. Its job is to just run. But on the other side, you have specialized code. Think about generating a complex user interface from a picture. That has to be incredibly efficient, not wasting a single cycle. Or even crazier, a cryptographic proof. That code has to be mathematically perfect. There is zero room for error.
Okay, so it sounds like we're really dealing with two very different, very specific problems. One is all about efficiency, and the other is about absolute correctness. Let's dig into that efficiency problem first, shall we?
Okay, so when an AI model tries to turn a UI design into code, it breaks everything down into these little units called tokens. And what the EfficientUICoder paper found is kind of shocking. Look at this chart. The image itself and the code it generates make up over 90% of all the tokens. It's like trying to describe the Mona Lisa by listing the color of every single pixel. It's just incredibly wasteful, and it totally distracts the model from what actually matters. Got it. So it's just drowning in unnecessary detail. That's the efficiency side. So what's the deal with the correctness problem in the world of crypto? Yeah, this quote from the ZKPs paper really hits the nail on the head. I mean, reasoning about finite field arithmetic, constraint systems, and gadgets, that sounds way, way beyond your average coding task.
It totally is. With something like a zero-knowledge proof, the code isn't just running a command. It's actually proving a mathematical statement is true, but without revealing any of the secret info. So it's less like writing a recipe and more like constructing a flawless logical argument in code. And that's where LLMs get tripped up. They can write code that looks right, syntactically correct, but the underlying logic, the semantics, is just flat out wrong. The proof is broken.
All right, moving on to the solutions. How on earth do you fix that massive inefficiency problem we talked about? Well, the team behind EfficientUICoder came up with a really clever approach to teach the AI how to focus.
That's right. They basically built a system to intelligently compress both the input image and the output code. The whole idea is to filter out all that noise we saw earlier, and it works in 3 key steps.
So first, the system scans the UI image and identifies only the most important things. The buttons, the text boxes, and their layout. It creates a simple element tree. Second, it gets even smarter, refining that selection. It might drop some low-importance details from a key area, but keep a high-importance detail from the background, like a specific brand color. And finally, as it's writing the code, it actively stops the model from doing something LLMs love to do, writing the same repetitive, redundant HTML and CSS over and over again.
Ah, I see. So you're not giving the AI the full, messy photograph. You're giving it a clean, summarized blueprint. And then you're acting like a supervisor, making sure it doesn't get stuck in those classic repetitive loops. That's smart.
Exactly. It's all about being economical with the information you give it. Okay, so that handles efficiency. But what about that second massive challenge, ensuring absolute perfect correctness in cryptography? The ZKPs paper took a really interesting approach. Instead of giving the LLM more freedom, they gave it less. It's almost like giving a junior developer a super strict step-by-step workflow they absolutely have to follow.
That is the perfect way to put it. And the technical term for this approach is an agentic framework.
So what does that actually mean? Well, an agentic framework is a system where the AI model, the agent, doesn't just spit out an answer.
Instead, it follows a structured process, using tools and getting feedback along the way to solve a complex problem. So instead of just saying, hey, give me the final crypto code, ZKCoder guides it through this careful multi-step journey. And this process is really cool. First, the LLM sketches out the problem's logic in a simple, high-level way. Then it goes and finds the right pre-verified code snippets, they call them gadgets, that it needs to build that logic. Finally, and this is the key part, it generates the code and then enters this interactive repair loop. It tries to compile the code. If it fails, it actually reads the compiler's error message and tries again. It just keeps doing that until it gets it right. No way, that is brilliant. So it's basically using the compiler as a source of truth, an oracle, to check its own work. That forces the LLM to produce code that doesn't just look right, but is actually verifiably valid. Okay, so we've got these two really sophisticated, really smart new approaches. But here's the billion-dollar question. Do they actually work? Do they turn our naive AI coders into a real expert? Well, the numbers are pretty staggering.
Yeah, they really are. Let's start with EfficientUICoder. The gains in efficiency were just huge.
First off, it slashed the computational cost by almost 45%. And on top of that, it made the whole process, the inference time, nearly 49% faster. I mean, for a developer, that's not just a small improvement. That's a genuine game changer for your entire workflow. Okay, that's a massive win for efficiency. So what about ZKCoder? Its goal was correctness. How did it stack up? Believe it or not, the improvement there was even more dramatic. So get this. When they just let the base LLM try to write these super complex crypto programs on its own, its success rate was a measly 17%. Pretty bad. But with the ZKCoder framework guiding it through that structured process, the success rate skyrocketed to over 83%.
Wow. Okay, so we're not talking about small incremental improvements here. These frameworks are fundamentally changing the game and unlocking new capabilities for these AI models.
So as we get to our final section, the future of AI coders, it feels like the big takeaway here isn't just let's build bigger and bigger AI models. It's really about building smarter systems around the models we already have.
That is absolutely the key insight. Whether you're forcing efficiency by compressing the data or you're enforcing correctness with a strict workflow, these frameworks are like expert supervisors. They take a talented but naive AI and elevate it to the level of a reliable professional.
And really, this shows us a path forward. This isn't just about UI or crypto. It's a blueprint for how we can tackle all sorts of other highly specialized fields, where you need more than just code that looks like it should work.
Which, of course, leaves us with one last, really fascinating question to chew on.
If we can teach an AI to master both the creative art of UI design and the rigid logic of cryptography, what area of human expertise could possibly be next? That's all the time we have for this explainer. Thanks for joining us.
Thanks for watching. We hope this sheds some light on the exciting future of AI and software development.